And let me set record on this. Now, the next three problems are dependent on the formula for the distance between 2 points. Okay? If I said, what's the distance between that point and that point? Well, first of all, let me help you memorize the formula. There's my point 3, 4, right? Here's my point -1, 5, right there. Notice that this distance is always the hypotenuse of a triangle if I were to draw a triangle. And what's the formula for the hypotenuse of a triangle?
A squared plus b squared equals c squared.
So c equals the square root of a squared plus b squared. Okay. Well, apply that to the distance formula here. Notice that one side is the difference in the y-coordinates. The other side of the triangle is the difference in the x-coordinates. So the distance of the solid line is still the hypotenuse, but now it's the hypotenuse of delta x squared plus delta y squared. And what is delta x? It's x sub 2 minus x sub 1. And what is delta y? It's y sub 2 minus y sub 1 squared. So that's the distance formula, and you got to memorize it somehow. Okay, and that's what they're giving us here. But that's a really complicated looking formula, and it gives a lot of people a lot of trouble. But if you always remember that what they're really talking about is the hypotenuse of a right triangle, then it won't be so hard to memorize.
Okay.
Because notice that the distance is the square root of the difference, the short side squared plus the other side squared. In other words, it's really the Pythagorean theorem in disguise. Okay? So let's do number 40. The 2 points are 4, 2 and -3/2, 2. So the distance between them. And let's always start out math problems with the general formula. What's the general formula?
X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared.
Okay, fill it in.
So it'd be -3/2 minus 4 squared plus 2 minus 2 squared.
Which is?
0. So it'd be 0 squared is 1.
Okay. So really what the distance between these 2 points is, if we happen to notice that the y-coordinate is the same, well, what's the square root of this squared? In other words, the square root of x squared is always x, right?
Yeah.
So we have this quantity being squared, but we're taking the square root of it, so our answer is going to be that quantity.
Okay.
In other words, it's equal to -3/2 minus 4. Well, that's -3/2 minus 8/2, which is -11/2. There's your answer. Okay. Now, hold on 1 minute. There is another way to figure this out that's a little easier when you have a vertical or a horizontal line. Notice that with this point, it's 4, 2, and it's minus 3/2, 2. In other words, the y-coordinate is the same. So that's a horizontal line. So I don't really need the distance formula, do I?
No.
Just need the distance between those two numbers.
Okay.
And again, you could say that's 4 minus a minus 3/2. So you still get 11/2, whether we use the distance formula or we don't. But remember that on horizontal lines and vertical lines, you don't really need the distance formula. You just need the distance between the two x-coordinates. If it's a vertical line, you need the distance between the two y-coordinates. That's it. However, rarely will they give you something where these are the same. In other words, they're not going to make it that easy for you. Let's do 41. Notice that neither one is the same as the other.
Yeah.
Give me the distance formula.
Y equals x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared.
Plug in our numbers.
So that would be negative 4 minus 4 squared plus 4 minus 4 squared.
Hold on, don't drop negative signs. It's the easiest thing to do in algebra is to drop a negative sign. This is 4 minus a minus 4.
So it'd just be 8.
Correct. Okay, so this one, what's this quantity? What's minus 4 equal to?
Oh, sorry. Minus 4. Is that negative 8?
And what's negative 8 squared?
64.
What's 4 minus a minus 4?
8. So
And
it'd be 64 again.
so we end up with the square root of 128. Now, that's not simplified, so that's not the answer we want to give. Can you find any factors of 128 where one of them's a perfect square number? What? Look back up here. What does that tell you?
Oh, because it wouldn't be 8.
2 times 64, right? In other words, 64 plus 64 is the same as 2 times 64. So I can write this as the square root of 64 times the square root of 2. And then 64 being a perfect square number gives me 8 root 2. And that's my answer. Okay. Now, notice one other thing in this formula. If I'm doing slope, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right?
Yeah.
And I got to go the same way. I could do 1 minus 2 as long as I do 1 minus 2 in the denominator. But I got to go the same way. Well, in the distance formula, you don't have to. In other words, because I'm squaring it, I could actually do x sub 1 minus x sub 2 there, and y sub 2 minus y sub 1 here. Because it doesn't matter whether the answer comes out negative or positive, I'm going to square it anyway, and that gets rid of the negative. That's why both of these came out to be positive 64. Because it didn't matter whether I was squaring negative 8 or positive 8. So that makes it a little bit easier. In other words, if you're doing the math here, I could do that minus that, which gives you 8 squared, plus, and now I can go the other way if I want. That minus that, which gives me 8 squared also. You do have to take the square root of those. But just to let you know that when you're doing the distance formula, you can go either way if it's more convenient. In other words, a lot of times it's more convenient to do 4 minus 2 than 2 minus 4. 2 minus 4 gives you a negative number. 4 minus 2 gives you a positive number. Well, with the distance formula, you don't care whether it's positive or negative. You're going to square it anyway. All right, number 42. Find the length of a diagonal of a square with area 16. Well, if the area of that square is 16, what's one side of it equal to?
4.
And so is this side. So how do I figure out that diagonal? Squares are always right angles.
Okay. So the 4 squared plus 4 squared equals c squared.
Remember, it's all, yeah, always start, whenever you're solving for the hypotenuse of a right triangle, which is what you're actually doing when you do the distance formula, you're always starting your answer out with square root up. 4 squared plus 4 squared equals square root of 32. And now simplify that. Are there any perfect square numbers in square root of 32?
16.
Yeah, and you actually do want the biggest one. There's a couple. 4 is also a factor of 32. But you want the biggest one, and you correctly picked the biggest one. That gets you to the answer the quickest possible way. So 4 root 2 is our answer. Notice, let's just talk about that for a second. I could have done 4 times 8, right? It's also 32, and that gives me 2 root 8. But that's not simplified. Root 8 is never simplified because that is 2 root 4 times root 2. That allows me to pull another 2 out, multiplied by the first 2, and I get to the right answer. So there's more than one way to simplify these things. The most efficient way is to find the greatest perfect square factor. 16 was greater than 4. So I was able to do the problem in one step using 16. Whereas when I used 4, I had to do 1, 2, 3 steps to get it to the correct answer. You still can do it, it's just a little lengthier. So you save yourself steps if you figure out what the greatest perfect square factor is of this number. So the greatest perfect square factor of 200.
Greatest square factor of 200 was, could you do 100 times 2?
Yep.
Until the...
Yep. In other words, here's the list you want to know, your perfect square numbers. So when you're looking to simplify a radical, always look to the maximum one of these that is a factor of the number that's inside your radical. And there's a factor, but there's also a factor. And if you use the biggest one, you'll be better off. In other words, I get to do this in one step only. Square root of 100 times square root of 2, which is 10 root 2. As opposed to if I'd have used 4, I'd still be working on it. I'd still get the answer, but it would take multiple steps. All right. Equations of a circle. Let's talk about that for a second. If I have a circle that is at the origin, whose center is at the origin, then the equation is quite simple. It's x squared plus y squared equals r squared, where r is the radius. In other words, if that was a radius of 2, I would have x squared plus y squared equals 4 would be the equation of that particular circle that I drew. Okay? Gets more complicated if the circle is not at the origin. By that I mean its center. Let's say that center is at 3, 4. Okay? Now the equation of this circle is x minus h, with h being the center's x coordinate, plus y minus k, with k being the center's y coordinate, equals r squared. So let's say this had a radius of 2. So what's the equation of that circle?
The x minus 3 squared plus y minus 4 squared equals 2 squared.
Perfect. All right, now let's do question number 43. To do 43, we have to kind of figure out where the center is. You can see my cursor. What do you think the center is?
Probably negative 2, 7.
Yeah, that's what I was going to say. Now we also need the radius. What's the radius?
3.
Yeah. So r equals 3. So now what's the equation of this circle?
X minus negative 2, so plus 2, squared, plus y minus 7 squared equals 9.
You got it. Circles are easy. I don't think we have to worry about graphing this, but I will. I think you know how to do it. Where's the center on number 44? Where's the center of my circle?
1, 4.
Right there. 1, 4. What's the radius of that circle?
3.
So it basically is going to go down to there. So that's how I graph it. That should go down to there. Okay? With that distance being 3. Okay? 45, where's the center of that circle?
Negative 3, 5.
What's its radius?
The square root of
which is 1.5.
Which is 1.5.
Yeah, it's just the square root of 225 is 15. So the square root of 2.25 is 1.5. So since this point here is negative 3 comma 5, I know that 1.5 doesn't go over very far, maybe to there. So there's a graph of that, where this distance is 1.5. Okay? Okay, let's go on. Piecewise functions. These give people fits, but they shouldn't. In other words, they're actually very simple. It's just let me go down. Oh, they did give us one problem. Okay. Yeah. 46. Good. We got time for one problem only of piecewise functions. There's the function they give us right there. And which function we use depends on what the domain reading is. In other words, what the horizontal axis is. If the horizontal axis is less than -1, then we're going to use this piecewise function on top. T squared minus 3t minus 8. Okay. If t is greater than -1, then we're going to use the straight line. Okay. So the function might look something like, it would be here's -1. So for everywhere left of that point, I would have the parabola. And then my other one is everywhere to the right of -1. And this would be a closed dot because it's greater than or equal to -1. This would be an open dot because it's just less than -1. Okay, so that the only thing is that piecewise functions are two different functions plotted on the same graph depending on the horizontal value. In other words, we separate this thing along that line right there. Everything to the left of the dotted line is t squared minus 3t minus 8. I may not have actually drawn it correctly, but it's approximately correct. And everything to the right of -1 is the straight line 5 minus 2y, or 5 minus 2t. So that is y equals 5 minus 2t. And this one is y equals t squared minus 3t minus 8. Okay? So to answer this problem, it's actually relatively straightforward. We got to figure out, first of all, which function we're going to use. So to figure out s sub 1, plug in -3, and which function are we plugging it into?
Let's see. The y equals t squared minus
Yeah, because t is less than -1, right? So I'm going to use the top function. Unfortunately, I have a 6:30 that I have to go to. It's a new student. So I'd rather not be late, so I don't know that I have time to finish this, but I think you're going to get the idea. So to figure out s sub 1, we're going to plug in -3 into this top function. Whatever that gives you, that's s sub 1. Now, to figure out s sub 2, t is minus 1, which function do we plug it into?
Say that again?
To figure out s sub 2.
Yeah.
First of all, we need to figure out which function we're going to plug it into. Well, what is t? T is minus 1. Which function does that go with?
The y equals 5 minus
Right, the bottom one. So plug in minus 1 and you get 5 minus a minus 2, or you get 7. So s sub 2 is 7. Now to figure out s sub 3, which function are you going to use?
the bottom one.
So s sub 3 is 5 minus 4, or 1. So which function you use depends on the value of t. If t is less than minus 1, you use the top function. If t is greater than or equal to minus 1, you use the bottom function. And it's as straightforward and simple as that. You just have to figure out which function you're using. All right, Madison, I'm going to let you go. We got through 46. I will talk to you next time.
All right, bye.